Okay, so we're looking at question 6 in this video. Now, it says show that the integral of negative f of x equals negative the integral of f of x. Now, I feel like we've already done this up here. If I made a k equal to -1, right? But we could do it in a slightly different way, I guess, although it's really all the same way. If we say let capital F of x, by the way, we're doing question 6 here, be antiderivative of f of x. Okay, so I can write this integral statement. We need to show that. So the procedure is start with your left-hand side, turn it into the right-hand side with some clever manipulation. So we start with the left-hand side. We've got minus f of x dx, and that will equal negative capital F of b. Right, so coming from this statement here, minus the negative of capital F A, kind of a bit squashed up here, but you get the idea. So that equals, pulling minus out of that statement, we'd have capital F of b minus capital F of A. Right, maybe just, that's like a minus minus makes a plus, or think of, I just pulled one minus out the brackets. Now this bit in here is the integral of f of x, yeah, and we've got the minus out the front. So there's the show that. That's not too difficult. It's what we've been doing in question 5. What is a little bit maybe new or might look a bit confusing is 6b. 6b. It's saying use, well, it's saying hence, but hence means use what you've just done to show that if f of x is smaller than 0 for x on this interval, all right, which it is, right, there's f of x on that interval between a and b, then the shaded area equals minus the integral of f of x dx. Then the area, all right. Okay, the area is minus the integral. All right, now there's the, apologies about that. There's the area, right? They're saying that the area would have to be minus of the integral. Now, I want to get rid of that. So, what you may not have seen yet is that integrals where below the x-axis come out to be negative, right? In fact, it's going to happen down here in C. Let's actually do one of those, and then we'll come back to this question, I think. So put some numbers in, and you're going to go, oh yeah, makes sense, right? So what do we got here? C1. Let's have a look at that. So it was the integral from 0 to 1, nice and easy. The function is minus x squared dx. That would equal the antiderivative, which will be minus x cubed on 3, evaluated from 0 through to 1. Okay, now we could write this. Just been doing these show that's, or no, I guess they're proofs really. And then we could say, well, it's the antiderivative of x squared. You add 1 and then divide by what you've added. You would evaluate it from 1 to 0, but you'd have to come in and take a minus of your answer, right? But you know, if f of x equals minus x squared, you can just say, well, the antiderivative, start with the minus x squared, but add 1, divide by 3, and that will work fine. So if I do it that way, I'm saying that this integral will be f of 1 minus f of 0, which in our case would be minus 1 cubed on 3, minus 0 cubed on 3, which is just 0, right? So minus 1 cubed, it's really 1 cubed minus is minus 1, and you've got that as your integral value, right? But if you then think about areas, so the original function here is y equals x squared. You know what happens. You have seen this before. Right, say I draw in a parabola. Y equals x squared. What happens if I whack a minus in front of everything? All the y values become negative, and we get this reflection. Yeah. So we've got this as our function. Right. Y equals minus x squared. We're looking at a little interval here. There's the area between 0 and 1. The integral value is coming in at minus 1/3. We've got this idea of signed area, because the area itself is just a third. Right? It doesn't really make sense to talk about negative areas, does it? It's like talking about negative lengths and widths. So you could say that, well, the area is a third, but the integral's giving me this negative value in here, okay? Which is fine, it's what we would expect. If I was to graph this, let's just think about the antiderivative for a minute so you know what y equals x cubed looks like, right? You get this kind of point of inflection, nice looking graph. The third will maybe stretch it out a bit like that, and the negative will put it the other way around. So instead of coming up like this, it's going to be more like that. Sorry, this is hard to draw with a pen, right? And we're saying if we're going from 0 to 1, right, you have to take whatever the value is there at 1, right? Spoiler alert, it's minus a third, and you subtract away 0, right? That value. So of course because this function's decreasing here for this interval, and because we're below the x-axis, we're ending up with negative values, right? It's actually the key idea is, that we're below the x-axis here, right? We're going to get negative values when we do that calculus, when we do the f1 minus f0, right? Or when we apply the fundamental theorem of calculus, okay? But nonetheless, the area itself would be positive, and I think that's where this question's going to go. Now, this statement here, so I want to get back to 6b now. This statement here, they've started off the sentence with a hence. It's the same as this, right? They're the same. Right? So when they say hence, they mean, well, use what you just did. Well, what I just did was that bit there, the minus f of x. And I think if we draw that on, okay, so like in the previous question, I had a negative function and it was reflected about the x-axis. Well, same thing here. Yeah, there we go. So that would be y equals minus f of x. Right. The area from A to B, for that, will actually be exactly the same as this area. Right. Maybe I could even label this. I could say, well, this is area A, and this is area B. But those areas, area A equals area B. They're the same area, but the integral here will be negative, and this one will be positive. So you could say, just read this, show that if f of x is smaller than 0, then the shaded area will be negative the integral value. All right, and really, well, the way I'm interpreting that is just to say, well, the area is positive. Now, the area itself is a positive number. Now, I could say, well, that statement there is equivalent to this. Yeah? And so then I can draw this function in. I can look at the area here. I could say, well, that area there is exactly the same as that area there. Right? Yeah. So I would, to answer this question, I'd draw the graph and then, just write a sentence, since area from A to B is the same for the two integrals, for both integrals. Maybe we should write it out properly. Minus f of x and minus regular old f of x, okay, then what are they wanting us to say here? The area here, then area B, I've called it, area B, right, would have to equal the negative, right, or minus 1, we'll just say negative, of the integral, right, equal negative multiplied by the integral value. Right? So it's possible to get these negative integrals under curves, and you will see them. I won't talk about it anymore, I don't think. But you're going to start seeing that. For some questions, you can imagine things like, functions. How do I clear everything? Yeah, maybe like a sine wave, right? Or I don't know. Maybe not a sine wave, but something that's, something like this. And maybe we're interested in a bit of area there and a bit of area here, from A to B or something. Well, when I do the integral and evaluate, I'll be getting those two areas. Right? Maybe that this area in here looks a bit bigger. Right? So the integral value would come out negative, right? Function. But the fundamental theorem of calculus is still holding. If I can work out the total of those values and get the signed area, you've just got to keep in mind that these areas here are going to be negative. Okay. All right, we can look at that in a bit more detail in the future. All right, thanks. Might leave it there. I mean, you can do these questions. What's happening? Yeah, you've got a quadratic there, x minus 1, so your roots are 0 and 1, which means 0, 1. It means that you're evaluating from 0 and 1, you're in here, right? So you should be getting a negative value there. Okay. What about this one here? If you're looking at a straight line graph, but where are you going from? -2, right, to 0. Well, that means you're looking at this area here, right? And so the integral values will be negative. What does it say? Yeah, calculate the following integrals. So you should just leave it as a negative answer. Give a graphical interpretation. So you could draw a quick sketch like that. This one, I think you've seen this before. Think of this as originating from a circle. Remember back to year 11 when you had circles and these relationships, x squared plus y squared equals the radius squared. In this case, the radius here is 2. If I start doing some rearranging, y squared equals, our radius was 2 squared, which is 4 minus x squared, square rooting. For this one, I think what I'd do is pull the negative out of the integral. But you should be fine with that question. Of course, the square root, you can't have negatives inside a square root, right? So I'll leave the question for you to do, but the graph is going to look like that. Although the negative will put it underneath, yeah? Okay. All right, we'll leave it at that. So good luck with these questions. Let me know if you have any further questions from the book. Thank you.